All right, it's certainly what Zoe has is I think good though. But is there any? You'll figure it out later. It's night as you're going to sleep. You're like, oh, that's why 10 divided by root 5 is 2 root 5. I would think so. Now again, Zoe didn't show any of her work. Are you okay with her not having showed her work? And the homework is okay. Everything's good. Are we allowed to start here? I want to make sure everyone's really just feeling great right now. Okay. You want to talk about? Oh wait, no, we have a joke first. Are you ready for a joke? I think by now you found it to be true, right? That my jokes are extremely, the ones I deliver to you are really high quality, like ones that you should just take with you, be able to use over and over
They grow
again.
exponentially worse.
This one's pretty. This one's a little bit low, but we'll go for it. Okay. Have you heard of a polar bear before? You've heard of polar bears, right?
Unfortunately, they dissolve in water.
No. Oh, that's a chemistry joke. We're in math class right now. Do you know what a polar bear is? It's actually not that hard. It's kind of somewhat obvious, really. It's it's the same as a rectangular bear, just after a change of coordinates, right? Oh. It's hilarious because we said it is, okay? All right.
I don't get why. That's not right. I'm sorry, that was such a low.
All right, we'll try better next time, okay? Let's talk about polar systems. Does that sound like a fun idea? We've done lots of things in rectangular coordinates in your life. Let's do everything we did in rectangular forms, rectangular coordinates, in polar coordinates, right? So like every task you might have had, Every task you might have had then, let's do it now. Like graphing things. Oh yeah, we did that. Check. Can we find the solution to systems in polar coordinates too? I give you 2 more, Ian. 1 right now. Go. Are you sure? You want to say? You sure? Do I think that's what you said? All right. The first task is to graph these. Okay. So that's going to be that's going to be for cameras. This is going to be the review of tomorrow's quiz. Solving systems is not on tomorrow's quiz. But the requisite skill for all of what we're doing today, one of the things we're going to ask you to do is graph all of these. That is on the quiz tomorrow, right? Being able to graph these equations is something I should have you should know how to do. What is? I don't think actually we've graphed r equals 4 before. It's not hard, but we've never done it. What is it? Yeah, it's just a circle centered at the origin of radius 4, right? Let's do it in blue. Something's funny. They must have told that polar bear joke in the hallway. What about the other one? How about I give everybody a second to do the other one? It's a video quick. Like I said, good quiz review. Graph a road, whatever it is.
Oh, for the one that
This is a set of all points in the plane that have an r value of 4, right? R stands for radius. So it makes sense, yeah. You want me to come over there? All right, are you? Yeah, it would be like a negative and 180 degrees. Yeah. Anything correct is cool. What is this? It's a rose curve, right?
It's a rose curve that makes plus like.
And the maximum is 4. There are 4 petals. The first one is in the 0 direction. Yes? Was that good practice for the quiz? There you go. Well, you'll probably have to graph a Rose curve or something, you know? Good. So what are we doing again? Let's not lose sight of what we're trying to do. It seems to be the case that maybe we have like 4 intersections here, don't we? Like seems like if we're talking systems, that's what we're interested in doing. It's a pretty picture. So let's not lose sight of what we're trying to do here. It seems like there are 4 solutions to this problem on the interval 0 to 2 pi, right? Let's take the other angle in our lives that we might approach this problem with, and that's just an algebraic view. Like, when are these just simply equal? Let's try. Solve it. This is your, I guess this is number 1. Okay, Ian, go ahead.
Does the system of equations also include where the radius is like -4?
I think maybe we need to have a discussion about that, right? Because I think you're highlighting an issue. What's your issue?
Because something in -4 in one direction will intersect with r equals 4, but at the same time, that would mean that r is not equal to 4 is equal to -4, yet it still intersects the graph of r equals 4.
Yeah, we have issues maybe like here, right? For example. Yeah.
Pi, 2 pi.
Yeah, 0. Well, where is cosine 1? Only at 0 and at
2 pi.
2 pi
So it's 0
and 4 pi, etc. So theta is 0.
pi,
That's a 0.
2 pi.
Pi. Ian. Thanks. All right. Is that cool? So if theta is 0, we get an intersection of 4 for r and 0 for theta. This pen, man, it's killing me. 4 comma pi and so on. The 2 pi is not in our interval. Now the issue is the one that Ian was bringing up, and that's that this seems to disagree with what we just said. Didn't we say we were going to get 4 solutions on this interval? So I'm going to call these the intersection points. But there are 2 other points that we didn't name that seem interesting to us too when we look at this. That is this point here, which wasn't just named, and this point here. So I don't know, you might call that point what? I don't know. What would you like to call that point? If you were just playing Battleship, what point is that right there? What would you want to name it? An infinite number of correct answers here, but what would you want to name that point? Huh? 4 pi over 2 would be, I think, the answer most of us would go for. And what about this point down here? What do you want to call that one? Sure, I think those are the most natural choices.
They aren't.
And I think we'll call those common points, because they are common to both graphs. But it's not true that there's a theta value that you can plug in to both equations and get 4, and have this point be generated. If you think it's pi over 2, if you plug pi over 2 into this equation, what do you get? You get -4, don't you? Well, this is if you plug pi over 2 into this equation, you get 4. Same down here. If you plug in 3 pi over 2 into both these equations, here you get 4. Here you get -4, and here you get 4 still, right? This always gives 4, of course. In some senses, it's kind of like the parametric deal with the lines. It's kind of like, yeah, they kind of intersect, but like not at the same time or something. If you were to watch these graph, it would be like this, right? What? Well, now you distracted me. Right there. And then we're back to there, right? Yeah, let's do it with a calculator. Yeah, that's let's get everyone should try that. Okay. Let's do it on the calculator and see how it looks. We have 4 as one of these,
Yeah, South American.
and 4 cosine
You know what that goes on? Cosine.
2 theta. let's do the little ball and path thing. Make sure I'm going from 2 to. Okay, are we ready? Let me make sure I'm in simultaneous mode. Okay. So whenever they hit, we'll say boom. Okay, it's like the official, I think, way we say. Okay. Here we go. Boom. But not so much there. Oh.
Wow.
Boom. And then like not so much there. And then
They don't.
boom.
Wait, how do you graph those at the same time?
You have to be in simultaneous. Anyway, that did a better job than my hands could do. All right, so yeah, so let's still name those. Let's give some love to these 2 points. Let's call them common points. So this will be are you okay with agreeing to call these intersections and versus common points? So the intersections, let's say, are the ones that arise, like, there's no argument about those, right? Everyone agrees that both graphically and algebraically these arise. But the common points, let's agree that those are places that both graphs have in common, but are not actually places that solve algebraically the system. And again, we just showed you that like maybe that corresponds to like 2 things being in the same place at the same time or something. Yeah, Shine?
How are the common points different from the internet?
So common points are like actually not solutions. Right? Yeah. So I mean you'll see like r equals 4, theta equals pi over 2 does not satisfy this system. If theta is pi over 2, you do not get 4 here. You get negative 4. That's what we're saying. Let's see over here. I'm right though. This is going to be good practice for tomorrow, right? You might have to graph a. Well, I don't know. What is that? What are those? You might have to graph one of these, right? We won't be solving systems on the quiz tomorrow. So again, I'll give you just a minute to just even conceive of how these look and graph them. Okay. Just as practice. You ever have to use the French? Somewhere else. Does anyone else want lines? You can label. There are more over here, by the way, if you ever need them. And you can print them off on Google Classroom. I have some. Huh? Did you send it around again? Maybe someone has more to say. Let's send it around again.
Y'all better sign up.
Y'all better sign up, says Kimber.
Yeah.
You might have had to change the part. Suggest something. How are your Lima songs going?
But I think it might be separate.
Because both of these, so we got 2 Lima songs here to graph. could. I'd have to be more specific. It's very general question. I don't know. I mean, I care more about the All right, let's graph these here. Ian, is this your second comment? Okay. All right, here we go. So this is your moment of truth. How'd you do? What's your favorite color? Yeah, yellow? Pink, okay. There's no pink. Purple. All right, in purple, 1 plus 2 sine theta. That's got to point up, right? 3, 1, 2, 3. Does it create an inner loop? Yes, it does. Goes to the pole. We got in these directions 1 for each of those directions. It's -1. Yeah.
How do you know it's there? How do you know how wide it is?
I don't. It's actually probably wider than that.
How do you know it crosses at the x-axis?
Oh, because I plugged in 0 and pi, and I got 1 and 1. So I know in the 0 direction it's 1 unit, and then it's pi rate. How about, yeah, and this one I'd like to see the 5 points I graphed probably. The origin, together with those 4 points. Yeah. I just plugged in all those 5, I mean, yeah, that's what I did. Because I've graphed a few limaçons before. So you graph the limaçon out of the wealth of your experiences with limaçons, right? Like, be like, I know that this has a loop, and I just know that a limaçon with a loop goes through pole, creates a loop, and if you want to know how big that loop is, just do the subtraction. It's -1, right? And if you want to know how big that big loop is, just add them. You get 3. And I don't know, what do you want to call that? The hips? Or 1, right? What do you want to call it? Okay?
So the loop is 1 because,
Yeah.
and then for the vertical,
Yeah. Again, but really what am I doing? I'm not really doing much more than just plugging in 0, 5 or 2. That's all really. Matthew, go ahead.
So the minimum would be -1.
Yeah. Yeah, the minimum is -1, but that's represented by us being on that inner loop. Yeah, everywhere on this inner loop we have an R value that's negative on the inner loop there. What's your favorite color, Matthew? Black? That is a little boring, but we'll go. Purple and black is nice. Okay. 3 minus 2 sine theta. That's another limaçon. This time it's pointing down with a maximum of. I mean, you could. I don't know. You plug in 3, 5, or 2 and just see what happens. You don't need to take my word for it. Isn't it true when you plug 3, 5, or 2 in, you get 5? Okay. I'm not crazy. And again, we get 1, 2, 3 in these 2 directions. And how about in the pi over 2 direction? Do we get an inner loop on this one? No. So something like that. It's not perfect. Well, it's not perfect, but it's good enough for what we're doing here. It should be perfectly symmetric. So something like that. Of course I will. We need to solve this still, don't we? So let's set these equal to each other. By the way, how many candidates at least do we have for common points / intersections?
3.
Looks like there might be 3, yeah. Yeah, my pen is failing on me here. All right. So solve that thing. What do we get?
You get everything but the easy ones.
Yeah, right? All right. So sine of theta equals 1/2, I guess, at the place of intersection. Oh, yeah. On this interval, we're talking about pi over 6 and 5 pi over 6, which I guess, how good is my picture? And the answer is not that great. Not that great. Should be at pi over 6 where they are intersecting. So, okay, it's all good though. I mean, I'm not emotionally disturbed by that at all. So what are the intersection points? Well, there r equals something, comma, pi over 6, and r equals something, comma, 5 pi over 6. That's a comma. What in the world? So what is the r value? I haven't actually thought about yet. Is it 2? Plug in pi over 6 to, should be either one of the equations. In both equations we should get the same r value if we're saying what we're saying. So yeah, pi over 6, sine of pi over 6. 2, I agree. And pi over 6, same? The symmetry demands that it probably both be 2, yeah, right? Good. But then we also have the other point which we maybe want to name a common point.
Well, it has to be.
It does.
Yeah.
So, I don't know, what do you want to call that point? Probably
1 pi over 2.
1 comma pi over 2 or something. What is going on with this pen?
Does it always cross?
What do you mean?
Oh, no.
No, yeah, it'll always cross both the x and y axes. Right. Yeah. Right.
What's the difference between intersection and common points? Because doesn't 1 pi over 2 still like intersect?
Well, yeah, but it's not actually. If you plug pi over 2 into these equations, let's just see. Do we get 1? Sine of pi over 2 is 1/2 times 2 is. Wait. Pi over 2. So we get. What do we get here? So it's 3, right? Not 1. If you plug pi over 2 into the purple equation, you get 3. Right? But that's because, so again, this if we graph these on your calculator, I think you'll see, as we graph them, watch what happens. Boom. Right? They're not here at the same moment. Boom. You can graph it on your calculator to check this, and then here we're here. And then boom. No. Yeah, graph it on your calculator in simultaneous mode like I did, you'll see it happen.
We have to like label like dot on it.
As long as you get these answers and you have a reasonably decent picture, I think we're good. Oh, you mean on the quiz tomorrow, like as you're graphing the leaps on or whatever? I mean, as long as it's clear. Is it clear what points, the points I have dotted on there, are they clear what they are from the picture? As long as it's clear from the picture, I think it is. But this isn't the point. You know, 3 comma pi over 2. I think that's pretty clear from the picture.
We should Bobby call combination with songs like this, Beatles and official terms.
Okay, that's very nice. I like it.
The Beatles.
One more to throw at you here. It's not a system really, but I thought it'd be fun, so there you go. First of all, see if you can figure out what I'm even asking. That's the first question. What am I asking? Alpha and beta. No guess. There's no guessing involved. You have to figure out somehow what. I guess kind of like what the domain of this picture is. Huh?
Or even the next test after the test.
There will be a time when you need to know, yes. I think I told you the other day you want to calculate parallel, find the area inside of that.
Okay, I got this.
Don't give it away yet, Ian. Let it work for a while longer. Don't say anything. No. So figure it out. Yeah, obviously I figured it out because I took a graphing calculator to make on my computer and made this somehow, right? So I told the computer how to graph it using some boundaries, right? And that's really what you're trying to discover. Is like if I were to put this in my calculator, don't use your calculator yet, but afterward when you're done, if you want to check it on your calculator, really, what am I asking for on your calculator? I'm asking for like what do you make theta min and theta max in order to get this picture, right? Isn't that what I'm asking for? I guess so. Yeah. So figure it out.
The origin of the problem
but the ordinate graph.
Not very easy with the polar coordinates, no. No. But I've been holding on. It turns out that everything we're doing polar coordinates can be very, very, very quickly and easily done at parametric coordinates too. No, but we could, it'd be fun.
Yeah. That might
And
actually
then-
be helpful for the time.
Let's talk about that, 'cause yeah, and then, so if we're talking about parametric coordinates, then can I move the flower? It's like, absolutely. You can express the full flower in parametric coordinates, if you want to do that. Then moving things in parametric coordinates is like, okay. What else was I say? Yeah. You'll have two numbers, right? An alpha and a beta, like 1, 1, 2. Well, there are an infinite number of pairs that work, right? Yeah. I guess the question I'm not for you too is like, what must be true at the beginning and end of the sentence? What's true at the very beginning of the sentence? What interesting things to think about at the beginning or the end of the sentence?
Both plus 2.
Not quite. So what else is showing
Just remember, so in a real square, you're gonna have 5 sections of but remember, that's just half of the so okay, so we need to
We're doing data, so that's like here. So like here. No, this is an extra.
oh, is it sure? Okay. So when you're drawing this, you're gonna have your 5 of these.
I know. All right.
Oh my gosh, I don't
Sit down. You make me nervous. Sit down. All right. Sit down. Sit down. You're making me nervous. All right. Did you figure out where the pedal starts and stops? Don't we need that to be true, right? You don't care. You just thought about it. Okay. Use the power of your mind. So what happens here then? What must 5 theta be? When is cosine 0?
5 theta must be pi over 2.
Pi over 2 or other things.
3 pi over 2. So you divide both of them by 5.
Ian, I thought you were done today with the counts. Did you? I don't think you did. Okay. All right, so that looks good. So I think is the answer for alpha and beta, that should be like pi over 10 and 3 pi over 10? Is that what it works? Wait, what? Huh? Wait, what?
It would be negative pi over 25.
That is not my list. You're saying that, okay, negative.
You go back one.
Yeah.
Like that? I left space there for you. I knew that was going to happen. Okay, so why isn't it pi over 10 to 3 pi over 10? I don't know. You're saying this is negative to positive pi over 10? I think I agree. Can we reason to why that's the right selection?
Well, when you're drawing it, you would start at 200 at 0, and then you go this way around the curve to complete it. So you're only going halfway around
Yeah, I mean, we also know that in our interval from alpha to beta, we need to include 0, don't we? In that interval, because that's when that happens. Okay, so theta equals 0 better be in your interval. And then, yeah, there are other options here too. It says give possible values for alpha and beta. You can also add 2 pi to both of those and have answers too, right? So, but that's probably the most natural choice, negative and positive pi over 10. Yeah. Is that what you said? Did you have the same answer?
No,
No.
we got
Got it.
double. So we got, okay, but the way Ivy explained it to me is that it should have 5 petals, right? This rose curve.
That's true.
I mean, if you're graphing out interval 2 pi over 5, shouldn't
Yeah, so each one happens in the space of 2 pi over 5 radians.
But you got the space of pi over 5.
No, I take that back. Each one happens in the space of pi over 5 radians. The rose curve, the whole rose curve gets graphed in the space of 0 to pi. The whole thing.
Oh, okay. That's odd.
Because it's odd. By the way, feel free to graph this yourself in the calculator and use that as your theta min and max, right? And you'll see. You'll see. Doesn't matter. You can start whatever. We just often on our calculator we set theta min to be 0, and so that's why we often see it start here. Oh, 2 different intervals that work. Graph it on your. Yeah. Yeah, and then whatever.
I apologize, I should have mentioned the negative.